Right, over to question 7. So for this system, we want to determine the tension in the cable. Okay, so we want to also find the force that the foot of the mast exerts on the sailboat. Okay, so let us find the tension in the rear cable as well as the force F for this particular system, given that the tension in the front cable is 5,000 newtons and each is making an angle as indicated in the diagram here. Okay, so for this system we have to consider the second condition of equilibrium, which requires that the vector sum of the torques for this particular system must equal to 0. Therefore, we are going to consider the torque on the left as well as the torque on the right, and when we sum these two, we must get a 0. Okay, so now we are saying for equilibrium to occur, the torque due to tension 1 must equal to the torque due to tension T2. Okay, therefore we can say torque due to T1 equals 10. Okay, the torque due to T1 is equal to 10 meters times T1 sine 45. Okay, 10 T1 sine 45. All right, so therefore we have 7.07 T1. Also, the torque due to T2 is going to be 10 times the value of T2 is given as 5,000 newtons. Therefore, we have 10 times 5,000 times sine 30, giving us 25,000 newtons. Okay, so that is the torque due to T2. So since we are saying that the two must be equal, the torque due to T1 must equal to the torque due to T2. Therefore, we can say tau 1 must equal tau 2 in this statement. Therefore, we can say this is our tau 1 and this is our tau 2. Therefore, we equate the two. We are going to have 0.07 T1 equals 25,000 newtons, from which we are able to obtain the value of T1 as 3,536 newtons. Okay, so we have found the value of T1, which is the tension in the other rope, rather the rear rope. Okay, so now to find the force F, this one here, notice that this system is as if the two ropes are pulling this guy upwards. Okay, so if they are pulling this guy upwards, then it means that this force is acting downwards. Okay, it is going to be acting downwards, and the normal force therefore will go upwards. All right, so now let us consider the forces in the Y. We have that F acting upwards as the normal minus T2 cos 60. Okay, T2 cos 60, notice here. Okay, so we have now the angle becomes this one. This will be our 60 degrees. Okay, therefore we are going to continue. We say T2 cos 60 minus T1 cos 45 equals 0. This is the sum of the forces in the Y. So we know the values of T1 and that of T2. Therefore, we are saying that F equals T2 cos 60 plus T1 cos 45. And if we simply substitute the values of T1 and T2 there, we should find the value of F as 6,830 newtons. Okay, so that's all for this question. Okay, so this one was quite short as well. All right, so we move on to the other set of questions for those doing medical physics. The video is going to be ready very soon. Just be patient a bit.